Interstellar Objects, Visitors from the Stars, by Aslan Adnan, M.A., Thursday, the 9th of July, 2026. The first interstellar wanderer. On most nights, if you look up at the sky, every object you see belongs to our own cosmic neighborhood. The object's moon circles Earth. The planets orbit the sun. The asteroids, comets, and dwarf planets all trace their paths around our star, bound by the sun's gravity. Even the distant, icy bodies beyond Pluto are members of the solar system's extended family. For centuries, astronomers assumed that every comet and asteroid they discovered was another member of that family. Yet there was always an intriguing possibility. Our Sun is only one star among roughly 100–400 billion stars in the Milky Way galaxy. Every star is born from enormous clouds of gas and dust. Around many of those stars, planets, asteroids, and comets also form. During the chaotic early years of a planetary system, countless smaller objects are flung into interstellar space by close encounters with giant planets. If this process happens throughout the galaxy, and today we know that it does, then interstellar space should contain an unimaginable number of lonely wanderers. These objects travel for millions or even billions of years through the darkness between the stars, occasionally passing through another planetary system before continuing on their journey. Astronomers expected such visitors to exist long before they found one. The challenge was that interstellar objects are incredibly difficult to detect. They are small, cold, and faint, spending almost all of their lives in the darkness between stars. Only when one happens to pass relatively close to the sun does it brighten enough to be seen by modern telescopes. Even then, the opportunity is brief. Such an object races through the solar system on a one-way journey, often giving astronomers only weeks or months to study it before it disappears forever. Everything changed in October 2017. One-Eye Oumuamua. The Messenger. On the 19th of October 2017, astronomers using the Pan-STARRS telescope in Hawaii detected what initially appeared to be another small asteroid. Within days, however, calculations revealed something astonishing. This object was traveling so fast that the sun could not capture it. Its orbit was not the elongated ellipse typical of a comet, nor the closed path followed by an asteroid. Instead, it followed a strongly hyperbolic trajectory, a path that could only mean one thing. It had come from another star. The object received the official designation One-Eye Oumuamua. The one eye means it was the first recognized interstellar object ever discovered, while the Hawaiian name Oumuamua roughly translates as scout, messenger, or a messenger arriving first from afar. It was a fitting name for humanity's first confirmed visitor from interstellar space. Although astronomers observed it for only a few weeks, Oumuamua quickly became one of the most studied and debated objects in modern astronomy. An object unlike any seen before. The first surprise was its shape. As Oumuamua rotated, its brightness changed dramatically, far more than is typical for asteroids. The simplest explanation was that it was extraordinarily elongated, perhaps resembling a cigar many hundreds of meters long, or possibly a broad, flattened object tumbling through space like a pancake. Later research has suggested that the flattened shape may fit the observations slightly better, but the exact shape remains uncertain because the object was too small and too distant for any telescope to resolve directly. Whatever its true appearance, it was unlike anything previously observed in our solar system. Its estimated dimensions are roughly 200 to 400 meters across, although the exact size depends on both its shape and how reflective its surface is. Asteroid or comet. Initially, astronomers classified Oumuamua as an asteroid because no coma, the glowing cloud of gas and dust surrounding an active comet, could be seen. Then, another mystery appeared. Precise measurements showed that Oumuamua was accelerating ever so slightly as it left the solar system. The additional acceleration was tiny, but it could not be explained by gravity alone. Normally, a comet accelerates when sunlight warms its icy surface. Escaping gas acts like miniature rocket engines, gently pushing the comet. Yet no gas or dust was detected around Oumuamua. This unexpected behavior sparked years of scientific debate. One possibility is that Oumuamua really was a comet, but one with unusually volatile materials that escaped without producing much visible dust. Another idea is that its surface had been altered by millions of years of exposure to cosmic rays, forming an insulating crust that hid most signs of activity. A more speculative proposal suggested that the object consisted largely of frozen hydrogen or nitrogen ice, although both ideas face significant challenges because such objects would be difficult to form and survive for long periods in interstellar space. The overwhelming majority of astronomers favor natural explanations, even though the details remain uncertain. The artificial object hypothesis. No discussion of Oumuamua would be complete without mentioning the idea that briefly captured headlines around the world. In 2018, Harvard astronomer Avi Loeb proposed that Oumuamua's unusual properties might be consistent with an artificial object, perhaps something resembling a light sail built by an extraterrestrial civilization. The suggestion generated enormous public interest but relatively little support within the astronomical community. Most researchers argue that while Oumuamua is certainly unusual, there is no compelling evidence requiring an artificial explanation. Nature often produces objects that surprise us, especially when we have only one example to study. Science advances by considering many hypotheses and then testing them against observations. Extraordinary claims require extraordinary evidence, and so far, no such evidence has emerged. What was it made of? Because Oumuamua was discovered after it had already passed its closest approach to the Sun, astronomers had only limited time to investigate it. No spacecraft visited it, and all observations were made from Earth. Its reddish color resembles that of many outer solar system objects, suggesting a surface rich in complex carbon-containing compounds that have been chemically altered by cosmic radiation over immense spans of time. Beneath that weathered surface may lie mixtures of rock, metals, and various kinds of ice, although exactly which materials remain uncertain. This uncertainty is itself scientifically valuable. Oumuamua reminded astronomers that other planetary systems may produce objects unlike those familiar from our own solar system. A messenger with more questions than answers. Ironically, the first known visitor from another star taught astronomers less about itself than they had hoped, but far more about what remained to be discovered. Before 2017, interstellar objects were purely theoretical. After Oumuamua, they became a new branch of astronomy. Astronomers realized that these wanderers carry samples of distant planetary systems across the galaxy. Every one of them is a natural probe, preserving clues about the conditions under which it formed perhaps billions of years ago around a star we may never identify. Yet, Oumuamua also taught an important lesson. If we wish to understand these rare visitors, we must find them earlier and study them more quickly. Fortunately, the solar system would not keep astronomers waiting long. Less than 2 years later, another interstellar traveler appeared, and unlike the mysterious Oumuamua, this visitor behaved exactly as astronomers had expected. Next, we'll examine 2I/Borisov, the first unquestionably cometary interstellar object. It provided a fascinating contrast with Oumuamua because, instead of raising more questions than answers, Borisov showed us that at least some distant planetary systems produce comets remarkably similar to those in our own solar system. 2I/Borisov, a familiar stranger. If 1I Oumuamua left astronomers scratching their heads, the second confirmed interstellar visitor was almost reassuring. Discovered less than 2 years later, 2I/Borisov demonstrated that not every object from another star would be mysterious or unprecedented. In fact, it behaved remarkably like an ordinary comet from our own solar system. That familiarity was exciting in its own way. It suggested that at least some of the processes that produce comets around our Sun may also operate elsewhere in the Milky Way. On the 30th of August 2019, amateur astronomer Gennady Borisov, observing from the Crimean Astrophysical Observatory with a telescope he had designed and built himself, noticed a faint fuzzy object moving against the background stars. As additional observations were made over the following days, astronomers calculated its orbit and quickly realized that it was traveling too fast to be gravitationally bound to the Sun. Like Oumuamua before it, Borisov had come from interstellar space. Following the International Astronomical Union's naming convention, it received the designation 2I/Borisov. The 2I identified it as the second confirmed interstellar object, while Borisov honored its discoverer, a reminder that even in an era of billion-pound observatories and sophisticated automated surveys, skilled amateur astronomers can still make discoveries that transform science. A comet in every sense. Unlike Oumuamua, Borisov revealed its identity almost immediately. As it approached the Sun, it developed a bright coma, the glowing cloud of gas and dust surrounding an active comet. It also grew a graceful tail stretching millions of kilometers into space. There was little doubt about its nature. It behaved exactly as astronomers expected an active comet to behave when warmed by the sun. Paradoxically, this ordinary behavior made Borisov extraordinary. For decades, astronomers had wondered whether comets orbiting other stars resembled those in our own solar system. Borisov provided the first direct opportunity to investigate that question. Although every planetary system is unique, the laws of physics are universal. Water freezes under the same conditions, carbon compounds form through the same chemistry, and gravity governs the motions of planets and smaller bodies in exactly the same way throughout the universe. Borisov suggested that the basic processes responsible for forming comets may be widespread across our galaxy. Looking inside another planetary system, comets are often described as dirty snowballs, although that phrase greatly oversimplifies their nature. They are better thought of as frozen time capsules. Most comets preserve material left over from the birth of their planetary systems. Because they spend most of their lives far from their parent stars, deep in the cold outer regions of space, they undergo relatively little alteration. When a comet approaches a star, sunlight heats its surface, causing frozen materials to vaporize. The escaping gas carries dust into space, allowing astronomers to analyze both using spectroscopy, the study of light. For the first time, scientists could perform this kind of chemical analysis on a comet that had formed around another star. Observations revealed familiar molecules, including water vapor, carbon monoxide, cyanide compounds, and other simple chemicals commonly found in solar system comets. Dust grains streaming from the nucleus also appeared broadly similar to those observed in many comets closer to home. One intriguing difference did emerge. Measurements indicated that Borisov contained an unusually high abundance of carbon monoxide compared with many well-studied solar system comets. The exact ratio depends partly on models used to estimate the comet's water production, but the overall conclusion is considered robust. One possible explanation is that Borisov formed in an exceptionally cold region of its original planetary system, where carbon monoxide ice could remain frozen more readily than in warmer environments. That finding illustrates an important lesson in science. Borisov was similar enough to be immediately recognizable, yet different enough to reveal that other planetary systems need not produce identical comets. Familiarity and diversity can coexist. Comparing the first two visitors, the contrast between Oumuamua and Borisov could hardly have been greater. Oumuamua appeared inactive, displayed no visible coma, possessed an unusually elongated or flattened shape, and exhibited a small non-gravitational acceleration whose precise cause remains under investigation. Borisov, by contrast, looked almost exactly like a textbook comet. It released gas, shed dust, developed a long tail, and behaved in ways astronomers have studied for generations. Yet the two objects also shared important characteristics. Both traveled on unmistakably hyperbolic trajectories, demonstrating beyond reasonable doubt that neither originated within our solar system. Both approached from roughly the direction of the constellation Lyra, although this is widely understood to be a consequence of the Sun's own motion through the Milky Way, rather than evidence that they came from the same stellar system. Their journeys through the galaxy before reaching us were almost certainly unrelated. Most astronomers conclude that both objects were ejected from their original planetary systems by gravitational interactions, probably involving giant planets. Just as Jupiter has flung countless comets and asteroids into interstellar space over billions of years, massive planets orbiting other stars are expected to do the same. If so, the Milky Way may contain trillions or perhaps even quadrillions of such wandering bodies. Can we identify their home stars? A natural question follows. If these objects came from other stars, can astronomers determine exactly which stars? Unfortunately, the answer is probably not. The Milky Way is constantly in motion. Stars orbit the center of the galaxy at different speeds while also passing one another over hundreds of millions of years. Once an object is ejected from its home system, it begins an independent journey through interstellar space that may last for hundreds of millions or even billions of years. Trying to identify its parent star is rather like attempting to determine which tree produced a single leaf after it has been carried around the world by changing winds. Using extraordinarily precise measurements from the European Space Agency's Gaia spacecraft, astronomers have attempted to trace the paths of both Oumuamua and Borisov backwards through time. A handful of possible candidate stars have been identified, but none can be regarded as a convincing match. Even tiny uncertainties in the present-day positions and velocities of stars accumulate over immense periods of time, making exact reconstruction increasingly unreliable. For now, both visitors remain travelers of the galaxy rather than ambassadors from any identifiable stellar system. Every visitor is a scientific gift. Borisov demonstrated something profoundly important. An interstellar object does not have to be bizarre to revolutionize astronomy. Because it behaved so much like a familiar comet, astronomers could apply decades of accumulated knowledge to interpret what they observed. Every spectrum, every photograph, and every measurement provided a glimpse into the chemistry of another planetary system. Instead of sending a spacecraft across light years of interstellar space, an undertaking far beyond our current capabilities, nature had delivered a sample to our own cosmic doorstep. Scientists are still refining some of Borisov's physical properties. Its exact size, internal structure, and the abundances of certain materials remain subject to uncertainty, and some quantities are inferred using well-tested but nevertheless imperfect models. By contrast, its orbit is exceptionally well determined from thousands of observations collected over more than 2 years, leaving no doubt that it originated beyond our solar system. When Borisov finally departed, it left astronomers with something they had lacked after Oumuamua: confidence. Interstellar objects were no longer once-in-a-generation curiosities. 2 discoveries in just 2 years suggested that such visitors are probably far more common than previously believed. The real limitation was not their rarity but our ability to detect them early enough. That prediction would soon prove correct. In 2025, an even larger interstellar visitor entered the solar system. Discovered while still approaching the Sun, it gave astronomers an unprecedented opportunity to study a traveler from another star before it made its closest approach. Next, we shall explore 3I Atlas, compare all 3 known interstellar visitors, examine what they reveal about the formation of planetary systems across the galaxy, and look ahead to a new era of discovery driven by the Vera C. Rubin Observatory, the Atlas Survey, and other next-generation sky surveys. 3I Atlas, a new window on the galaxy. When 1I Oumuamua was discovered in 2017, astronomers had only a few weeks to observe it. By the time they realized just how unusual it was already speeding away from the Sun. When 2I Borisov arrived in 2019, the situation improved. Because it behaved like an ordinary comet, astronomers were able to study it for many months and analyze the gases and dust escaping from its nucleus. Then came the third visitor. Discovered on the 1st of July 2025, 3I Atlas became the third confirmed interstellar object ever observed passing through our solar system. Unlike its predecessors, it was detected while still approaching the Sun, giving astronomers an unprecedented opportunity to organize a global observing campaign using some of the world's most powerful telescopes, both on Earth and in space. NASA Science. Far from being simply another addition to a shortlist, 3I Atlas marked the beginning of a new era. For the first time, astronomers could study an interstellar visitor in a systematic way, following its evolution before, during, and after its closest approach to the Sun, a comet from another star. Unlike Oumuamua, 3I Atlas immediately revealed itself to be an active comet. Even while still far from the Sun, it possessed a diffuse coma, a cloud of gas and dust escaping from its icy nucleus. As it traveled deeper into the solar system, solar heating increased its activity, causing the coma to grow and a tail to develop naturally behind it. This behavior left little doubt that the object was a genuine comet, rather than an inactive asteroid-like body. Its orbit was unmistakably hyperbolic. When astronomers traced its trajectory backwards, it clearly originated from beyond the solar system, making it only the third confirmed interstellar object ever recorded. It posed no danger to Earth, passing no closer than about 1.8 astronomical units, approximately 270 million kilometers from our planet. Bigger than the first 2? One of the first questions astronomers asked was, how large is it? The answer, perhaps frustratingly, is that nobody yet knows with precision. Estimating the size of an active comet is surprisingly difficult, because the nucleus is hidden inside a bright cloud of gas and dust. What telescopes see is often the coma rather than the solid object itself. Early estimates suggested that 3I Atlas could be substantially larger than either Oumuamua or Borisov. However, the range of published estimates remains wide because they depend on assumptions about the comet's reflectivity, activity, and the contribution of its surrounding coma. As additional observations continue to refine these models, astronomers expect the uncertainty to decrease. NASA Science. This uncertainty is not a weakness of astronomy. Rather, it illustrates how science works. Initial measurements are continually improved as better observations and more sophisticated analyses become available. Reading the chemistry of another planetary system. As sunlight warmed the comet, frozen materials vaporized and escaped into space. These gases absorbed and emitted light at characteristic wavelengths, allowing astronomers to identify many of the chemicals present. Observations detected familiar cometary ingredients, including water, carbon dioxide, carbon monoxide, and cyanide compounds. Later observations also revealed a rich and evolving chemistry as the comet responded to increasing solar heating. None of these discoveries suggested anything artificial or unexpected. Instead, they reinforced the growing picture that planetary systems throughout the Milky Way produce comets using many of the same basic ingredients found in our own solar system. At the same time, subtle differences in the abundances of these chemicals are scientifically valuable. They provide clues about the temperature, chemistry, and environment in which the comet originally formed, perhaps billions of years before our own solar system even existed. Comparing the three visitors, taken together, the three known interstellar objects tell a fascinating story. Oumuamua remains the great mystery. Its unusual shape, lack of an obvious coma, and small non-gravitational acceleration continue to be investigated, although the overwhelming scientific consensus is that natural explanations are sufficient. Borisov showed us that at least some interstellar objects are entirely familiar. It behaved almost exactly like the comets astronomers have studied for centuries. Three Eyes Atlas occupies an important middle ground. Like Borisov, it is clearly an active comet. Yet because it was discovered much earlier in its journey through the solar system, astronomers have been able to observe it with far greater precision and over a much longer period. Every new observation helps refine our understanding not only of 3I/Atlas itself, but of interstellar objects as a whole. Rather than treating each visitor as an isolated curiosity, astronomers can now begin to compare them statistically, a crucial step in transforming isolated discoveries into a mature scientific discipline. A new generation of sky surveys. Why have all three interstellar objects been discovered within less than a decade? It is almost certainly not because they suddenly began visiting the solar system. Instead, our telescopes have become dramatically better at finding them. Modern automated surveys repeatedly photograph the entire sky every few nights, comparing new images with earlier ones to detect moving objects. Sophisticated computer software identifies anything that changes position, allowing astronomers to recognize potentially interesting objects almost immediately. The Asteroid Terrestrial Impact Last Alert System, ATLAS, originally developed to detect potentially hazardous asteroids, has become one of the world's most successful surveys for discovering transient objects, including interstellar visitors. An even greater leap forward is now underway. The Vera C. Rubin Observatory, equipped with the largest digital camera ever built for astronomy, is designed to survey the entire southern sky with extraordinary sensitivity. Astronomers expect it to discover many more interstellar objects, perhaps dozens during its first decade of operation, transforming what is currently a sample of 3 into a population large enough for detailed statistical study. Messengers from other suns? Every interstellar object is a messenger. None carries an intentional message. None was sent to us by another civilization. Instead, each carries something equally valuable: physical evidence of how planets, comets, and asteroids formed around another star. Long before humanity possessed telescopes, these objects began journeys lasting hundreds of millions, and perhaps billions of years. They wandered through the vast darkness between the stars, crossing unimaginable distances before chance brought them briefly into our solar system. For a few short months, they become accessible to our instruments. Then they disappear once again into interstellar space, perhaps never to encounter another planetary system. The discovery of 3 such visitors in less than a decade has changed astronomy profoundly. What was once a purely theoretical prediction has become an active field of scientific research. More importantly, these discoveries remind us that our solar system is not an isolated island. It is one small member of a vast galactic community of stars, each with its own history, its own planets, and its own population of wandering comets and asteroids. The next visitor may already be on its way. When it arrives, humanity will be waiting with better telescopes, more powerful spacecraft, and a deeper understanding than ever before. And with every new messenger from the stars, we shall learn a little more about our place in the galaxy.
The author has placed this work in the public domain It may be freely imported, exported, shared, distributed, edited, modified, or reformatted without explicit consent from the author. As a visually impaired person, the author asserts his rights under the Marrakesh Treaty to facilitate access to published works for persons who are blind, visually impaired, or otherwise print disabled. 2013, wipo.int.
Early bird registration for my September 5th event is valid until July 31st for a minimum donation of 150 ringgit. Made before July 31st, you can attend my September 5th event. All proceeds for all your donations will be used not just for your meal for the day, but also for my various eye treatments and sponsoring some persons with disability to attend the event. From July onwards, it will be 150 ringgit until the end of July. Then in August, it will go up to 200 ringgit. Thank you.
How to attend Aislan Adnan's Meet the Author Luncheon at the Hungry Tapir, 135 Petaling Street, Kuala Lumpur. Short walking distance from the Pasar Seni MRT LRT station. From 12:30 hours, Saturday, 5th September 2026.
Step 1. Download all my 30+ books on nutrition for free from Z Library using this URL. However, there is a limit of 10 downloads a day from Z Library. The workaround is to download them, and 2,250 plus others, from my Optimal Health Community Telegram broadcast channel at EPUB Electronic Publishing. All my free ebooks are published in .epub electronic publishing format. If you are still living in the dark ages and only know .pdf, portable document format, and never heard of .epub, don't worry. You are about to have a mind-blowing experiential learning journey. If you use an Apple device, .epub files open in the Books app. If you are an Android user, use Universal Book Reader or a similar app. If you need further instructions on how to read .epub documents, just ask your favorite AI app to teach you. If you have never used an AI app before, start with Grok, Gemini, or ChatGPT. Then move on to DeepSeek, Claude, or Kling later.
Step 2. I have put all my books in the public domain, and you may share them freely. In fact, I strongly implore you to do so. Viralize them, make sure they reach every person who needs the knowledge contained in them. In Malaysia, the most recent data from the National Health and Morbidity Survey 2023 shows that 21.8% of adults are obese and 32.6% are overweight. This means the total combined rate is 54.4% of adults. Scary huge percentages of Malaysians are diabetic or suffer from other non-communicable diseases, NCDs. To be specific, in Malaysia, about 15.5% of adults have chronic kidney disease, CKD, up from 9.1% in 2011. Around 21.4% of adults aged 30 and above are at high risk of cardiovascular disease, CVD. Among older adults, about 8.5% have dementia, equating to roughly 260,000 people as of 2022. A nation is only as strong as its human capital. How strong can a nation be if more than half its population is fat, sick, and nearly dead? Of what good can you be to your family if you are fat, sick, and nearly dead? You owe it to yourself to be the best version of yourself that you can possibly be.
Step 3. Read the books, follow whatever advice that makes sense to you. If something doesn't make sense to you, or causes cognitive dissonance, you can ask me clarifying questions on the 5th of September. Also, be prepared to report on the 5th of September what improvements in your health you have noticed. So far, one person has seen her total cholesterol level drop from always above 5 to 4.6. Another has resolved a chronic constipation issue. I have written 2 books on human stool classification and stool analysis. Another person who wakes up every morning with a white layer of mucus on her tongue for more than half her life, now wakes up with a clear tongue. Step 4. Make the minimum donation by the required dates. The longer you prevaricate, the higher the minimum donation gets. Minimum donation per pax: 100 ringgit for donations received by June 30th, 150 ringgit for donations received by July 31st, 200 ringgit for donations received by August 31st, 500 ringgit for donations received by the 5th of September and for walk-ins. Places are limited. However, I do not wish to deprive anyone. If enough people register, we can take over the whole restaurant, so make your donations early to reserve your place. Purpose: your donations will go towards sponsoring persons with disability, PWD, to attend the event and also towards my various ongoing eye treatments. Sponsorship: if you run a business and wish to promote your business, you can sponsor door gifts, gift vouchers, or even cash.
Vegivore Food Therapy proudly presents Ask Me Anything on nutrition.
Your attention please. Vegivore Food Therapy proudly organizes a unique, transformative event on Saturday, 5 September 2026, starting at 12:30 hours at the Hungry Tapir, 135 Jalan Petaling Street, 50000, Kuala Lumpur. For a minimum donation of 100 ringgit, attendees will secure a seat at this rare opportunity. Aslan Adnan, MA, polymath and autodidact, will guide the session. A writer and researcher in nutrition science, Aslan has authored dozens of books on plant-based bioactives, antioxidants, and the chemistry of whole foods. In this session, he will lead a dynamic Ask Me Anything on nutrition session. All 30 of his nutrition books are in the public domain and are downloadable at the link below. Attendees must read these books in advance and come prepared with their questions. This is a singular chance to engage with one of today's leading independent nutrition thinkers. Don't miss it. A healthy, whole food, plant-based lunch with the menu curated by Aslan Adnan will be served. No need to write your name in the reference of the bank transfer, as it will automatically be displayed, but include your phone number in case we need to contact you for any last-minute changes.
We will also celebrate Aslan's 68th birthday.
Some of you have been wondering why a YouTube channel devoted to green political philosophy and ideology would address health issues. The stark facts are these. Data from the National Health and Morbidity Survey in Malaysia 2023 shows that 54.4% of adults are either overweight or obese, with 32.6% classified as overweight and 21.8% as obese. Abdominal obesity, per Roque Roy, was also reported at 54.5%. Compared to 2011, the combined prevalence of overweight and obesity has increased from 44.5% to 54.4%. According to the same survey, 15.6% of adults in Malaysia have been diagnosed with diabetes, kencing manis. Additionally, about 21.4% of Malaysian adults aged 30 and above have a high 10-year calculated risk of developing cardiovascular disease, CVD, sakit jantung. In Malaysia, precise prevalence data for diagnosed CVD is somewhat limited. Data from 2010 to 2021 indicated that 16.6% of all registered deaths were due to CVD. A 2015 survey found that 14.1% of working-age adults had diabetes, 24.5% had hypertension, and 45.9% had high cholesterol. The World Heart Federation also noted in 2022 that around 11% of deaths in Malaysia are linked to CVD. In 2011, the prevalence of chronic kidney disease, CKD, sakit buah pinggang, was 9.07%. A nationwide study in Malaysia in 2018 estimated that 15.48% of adults, over 5 million people, have CKD. It really is alarming. These numbers are striking, especially when you consider how rapidly they have grown over just a decade. It is a massive public health challenge. In light of these statistics, the implications for nation building and capacity building are stark. What value does a nation have if more than half its population are fat, sick, and nearly dead?
Are you fat, sick, and nearly dead? Well, according to the data from the latest survey, 54.8% of Malaysians are. In fact, the statistics are quite scary. So if you or any of your loved ones are in this high-risk category, don't despair. I have good news for you. I've written more than 30 books on nutrition, and you can download them all for free. The only limitation is you can only download 10 books per day from Z Library. However, you can download almost 2,500 books from my Telegram broadcast channel. I'll give you the link shortly. And if you're overwhelmed by 30 books, in fact, these 30 books, I've designed them so that they could cover the undergraduate syllabus of a nutrition or dietetics course, or the nutritional needs for a medical student. Anyway, if you think you're overwhelmed, you don't know where to start with this book. And then as you progress, you can, go deeper, take a deep dive into the other books. And if you want to meet me to discuss what you've read in the books, you have a chance in September to do so. However, there are 5 places already been taken up, and there are limited seats, so the sooner you register, the sooner you'll reserve a place for yourself. Attendance is by donation, so details are in the following video.
It is for this reason that I've written more than 30 books on health and nutrition and put them all in the public domain. Why nutrition? Because nutrition is the single biggest factor and lowest hanging fruit we can address to improve our health. 80% of our health is influenced by nutrition, which is our biggest exposure to the environment. The others are genetics, at 5%. But even with genetics, the emerging science of epigenetics shows how we can switch off bad genes and switch on good ones with nutrition. The remaining 15% relate to other lifestyle factors, including sleep, meditation, relationships, air quality, and so forth.
Important note on event registration fees. Super Early Bird. Donation received by the 30th of June 2026. Minimum donation of 100 ringgits. Early Bird. Donation received between the 1st and the 31st of July 2026. Minimum donation of 150 ringgits. Normal registration. Donation received between the 1st and the 31st of August 2026. Minimum donation of 200 ringgits. Late registration. Donation received between 1st to 5th September 2026. Minimum donation of 500 ringgits. All proceeds after deducting third-party costs will go towards Azlan Adnan's various ongoing eye treatments to hopefully reverse or at least arrest his macular degeneration, cataracts, photophobia, mydriasis, dry eyes, and etc. This is mission critical as, if his vision fails, he'll no longer be able to produce, edit, or upload videos. Your voluntary contributions and donations are a critical success factor. As such, your generosity, empathy, compassion, and kindness are well and truly appreciated. We thank you in advance for your invaluable help and assistance in making this event a resounding success.
About the author. Aslan Adnan, M.A., is a writer and independent researcher whose work focuses on nutrition science, food systems, and the biological foundations of human health. His writing examines how natural foods contain complex compounds that interact with human physiology in ways that may support long-term well-being. He has a particular interest in plant-based bioactive compounds such as polyphenols, carotenoids, flavonoids, and other phytochemicals found in fruits, vegetables, herbs, spices, algae, and fungi. His research explores how these compounds function in plants and how they may influence human nutrition when consumed as part of a balanced diet. Aslan approaches nutrition from a multidisciplinary perspective, drawing on biochemistry, plant biology, and public health nutrition. His work aims to translate complex scientific concepts into clear explanations so that readers can better understand the nutritional value of everyday foods. He is the author of several books examining natural sources of antioxidants and other dietary compounds. Author of the Antioxidant series, Antioxidants in Herbs and Spices, Antioxidants in Algae, Microalgae, and Fungi, Antioxidants in Fruits and Vegetables, Antioxidants in Nuts and Seeds, Antioxidants in Berries. Author of the Nutrient series, Macronutrients, Volume 1, Carbohydrates, Macronutrients, Volume 2, Lipids, Macronutrients, Volume 3, Proteins, Micronutrients, Vitamins, Trace Elements, and Minerals, Anti-nutrients, the hidden blockers in your food, Phytonutrients, the quiet power of plants, Water, the forgotten fourth, a macronutrient you can't ignore. Other books on health and nutrition. Tuber's briefing paper, 2nd edition. Aslan's 5-Powder Manifesto. Eating the Greek Way, how cultural habits support health without trying. Ideology on a Plate, how Robert F. Kennedy Jr. turned U.S. dietary guidelines into a scientific farce. Maslow in 2026, a practical guide to actual needs, not scrollable wishes. These works form part of an ongoing series exploring the chemistry, biological roles, and nutritional significance of bioactive compounds in plant foods. Through his writing, Aslan advocates a practical food-first approach to nutrition. His work emphasizes whole foods, dietary diversity, and balanced eating patterns, rather than reliance on isolated nutrients or supplements. He holds a Master of Arts in International Business and Management from the University of Westminster in London, and writes extensively on nutrition science, health, and food-based approaches to long-term well-being. Aslan Adnan, the quiet revolutionary of real food writing. Aslan Adnan, M.A., is a Malaysian polymath who spent decades turning food into philosophy. Raw, unfiltered, no hype. You won't find him pushing superfoods or miracle diets. He dissects what actually works. Whole plants, spices, microbes, and the quiet chemistry that keeps bodies humming. With over 30 books, self-published, shared freely on Z-Library, Facebook groups, Telegram channels, Aslan's output is prolific. Part manifesto, part manual. Early works like Spring Has Sprung, a psychological thriller, and travelogues On the Road to the East Coast reveal his roots in journalism, advertising, and storytelling. But nutrition became his mission. Educated with a Master of Arts in International Business and Management from the University of Westminster, London, he taught at the School of Management, Royal Holloway, London, while pursuing doctoral research in business strategy and environmental management, specializing in the international timber trade. That academic backbone, rigor, systems thinking, sustainability, bleeds into his food writing. No fluff, just evidence. The core series, the Macronutrients Trilogy, Volume 1 on carbohydrates, glucose, fiber, metabolism, Volume 2 on lipids, fats, omega-3s, inflammation, Volume 3 on proteins, repair, enzymes, muscle. Then micronutrients, water, and anti-nutrients, the plant world's double-edged sword. Anti-nutrients are naturally occurring compounds in whole foods, phytates, oxalates, lectins, goitrogens, that can bind minerals, block enzymes, or mess with absorption. They evolved as plant defenses, but in us, they steal iron from spinach, calcium from kale, or spike gut irritation from raw beans. Variety wins. 30 plants a week, not monodiets. Raw's romantic, but cooked smarter. Add spice blends like Aslan's 5-powder manifesto, turmeric mixes for real anti-inflammation, and you've got a library that says, eat wide, not weird. Why release it all into the public domain? Because knowledge isn't currency. It's oxygen. Aslan watched corporations gatekeep health, paywalls on papers, patented supplements, proprietary blends that hide what works. He refuses. His books aren't for sale. They're for spread. No DRM, no ads, no ego. Just files anyone can download, print, share. He says it plain. If one person in a kampong swaps white rice for brown or steams kailan instead of boiling it, that's the win, not royalties. He's no gatekeeper. His Facebook, Aslan Green Party, Instagram, and YouTube drop bite-sized truths. Traffic light WFPB guides, eye health talks on lutein, vegan journeys. He credits tradition, curries, forest mushrooms, seaweed from tides, and lives it. Unpeeled carrots, home ferments, no moralizing. 30-plus titles aren't about volume. They're depth. Carbs to phytonutrients, water to gut bugs. Aslan doesn't sell health. He hands you the tools. Read him and your plate changes. Not because you're broken, because you're built for better. A heartfelt light. To every soul whose hand did give, you've helped me dream, helped me live. In darkest hours your light came through, with hearts so kind, so pure, so true. Your gifts, like stars in deepest night, have steered me gently toward the light. Each coin, each word, each silent prayer, a thread of hope so rich, so rare. My eyes once dimmed now seek the skies, and slowly clearer visions rise. Because of you, I dare to see the world again. Its grace, its plea. Your compassion's flame will not just stay with me alone. It lights the way for others wandering through despair to feel the warmth of selfless care. You've shown what love in action means, in quiet ways through giving scenes. You've built a bridge from soul to soul and made the broken feel more whole. So let this thanks rise like a song, a melody both soft and strong. May your example gently call more hearts to rise to give. To fall into the joy of lifting pain, of planting hope where none remains. Your kindness walks beside me still, a light, a love, a living will.
now button to show your support. Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.